Next up, we have Luke. He's going to be talking about modularization in the app. Like, he's been working with a lot of engineers, and he's seen through the development of ANZ Plus app from literally the first piece of code that was written for the app all the way till what it is right now, I suppose. So yeah, he's going to talk about his experience and modularization with such a large engineering team. So the stage is yours.
Thank you. But before I do that, come in. Before I do that, I'm going to let everyone come in and get settled down, and I'm going to take a selfie because here we are. So happy to see everybody here in the audience today. All right, come in. There's still space. Although maybe towards the back of the room, perhaps. Hey, come in. There's still even a little bit more. All right, so yes, welcome everybody to my session. If you couldn't tell, I'm absolutely pumped to see everybody here today. I'm a principal developer at Mantel Group, but by trade, I'm an Android engineer. For quite a while, my passion has been building and leading high-performing, inclusive, and diverse teams. I've worked with a really wide range of teams and clients, all the way from tiny little startups to large projects with over 80 Android engineers. So today, if you couldn't tell by the slide, I'm going to be talking about the principles of modularization. But I'm going to start my talk by asking a question. Have you ever made a bad choice? Yeah, it looks like a few people in the audience might have. What happened? Have you ever made a good choice for the right reasons, but then things changed and it was no longer such a good choice anymore? How long do you stick to your principles if they're leading you to the wrong place? This is a story about how I made a mistake. It's a story about how code reflects who we are and our values. And it's a story about how to evolve and change a large code base and how to evolve and change a large team. So let's introduce that code base and that team. We're going to be talking about the ANZ Plus application. I spent 4.5 years, 4.5 years on the project, leading the Android team. If you're not aware of it, ANZ Plus is essentially a brand new digital bank built from the ground up. It's got all kinds of exciting features, both from a technical and from a user perspective. And by any measure, the program has been a great success. The app's been really popular. It's currently about 4.8 stars in the App Store, and it's rapidly acquiring customers. So quickly, in fact, that if you just take ANZ Plus as its own thing, it would be the fastest growing new digital bank in Australia. On the engineering side, the team grew from 5 developers in a room to one of the largest mobile teams in the Southern Hemisphere. And because this question always gets asked at the end, the numbers you see here are just mobile engineers, not product owners or testers or BAs or anything. This is iOS and Android developers. There are over 150 of them in the team. This graph overlays the monthly commits into the code base. And what's really interesting is, for the most part, contributions have scaled with team size. The more people we add, the faster we go, which is not necessarily true for all of the projects that I've been on. One of the reasons that the team was so successful is that right at the beginning, we had a strong set of values. Do the right thing and do the thing right. Own it. A unified team building a unified app. Care personally and challenge directly. So how is this code base organized? Android uses the Gradle build system. And Gradle allows you to break the code base up into independent modules that depend on each other. Each module includes code, resources, Gradle build scripts that define its dependencies. Modularization is used to isolate code and improve the build speeds. But the right way, the correct way to do modularisation has been a subject of discussion within the Android community. There have been a lot of words written on the topic, a lot of presentations, but I don't think as a community we've really landed on one right, correct, universally correct, satisfying answer on how to do this. So right here, at the start of the project, we had a very simple code structure. The app was split into only two modules: an app module that contained all of the UI, the view models, and a service module which contained the various business logic, stored data, communicated with back-end web services. For an app with such large ambitions, why did we choose such a simple structure? It came back to our values. And in particular, our value of being a unified team building a unified app. What does a unified app mean? It means that you don't go into different parts of the ANZ Plus application and get a UI that looks and behaves totally different in different sections. It means that the code is consistent, no matter what part of the code base you're looking at. We wanted to have no silos within the team. Everybody on the team should be able to change anything if it was an improvement, if it was going to make things better. So having a single unified code base is a great match for having a single unified team. Why is that? It comes back to a software engineering principle known as Conway's Law, which states organizations who design systems are constrained to produce designs which are copies of the communication structures in those organizations. Or to put it even more simply, the structure of your app will mirror the structure of your team. And this relationship works both ways. The structure of your code base can and does influence your team structure and the values that you have as a team. We wanted a unified team and a unified product, and so we had a unified code base. And there are lots of things to commend this approach. It's simple, quick, and easy. It broke down silos in our team and helped us stick to a consistent code style and user experience. And ultimately, it's just the simplest possible thing that works. There's no need for any further complexity. And I'd highly recommend this approach for small teams and simple apps. It was a great reflection of who we were and what we valued. The thing is, the ANZ Plus mobile team and code base were rapidly growing. By late in 2021, we were no longer a simple code base or a simple team. You can see from this graph that we started to hit an inflection point where contributions decoupled from the number of engineers. We were throwing more people at it, and just the same amount of work was getting done even without those people. Things were slowing down. What happened there? One of the things that occurred is that we'd started to hit scaling problems with our values. And I want people in the audience there to warm up your hands and warm up your voices, because I'm about to ask for a bit of audience participation. We found that two of these values did not scale as the team grew. Have we got anybody there in the audience? Just yell out who would care to guess what the values that don't scale were. Own it, unified team. What about down at the back? Own it, we reckon. Anybody else care to hazard a guess? Care personally. Ooh, interesting. Any other guesses? Yep. Sorry, I didn't quite hear that one. The third one, unified team building a unified app, and here in the middle. Do the right thing. Do the right thing. Wow, this is a real wide variety of guesses we've got here. The ones that didn't scale were own it and a unified team building a unified app. People generally kept doing the right thing. Everybody, even in a large team, cared a lot and definitely challenged directly. But one of the problems we had with own it, why was this one an issue? It's as the team grew larger and larger, the bystander effect became very real. People would see things broken in the code base and go, you know, there's 40 other engineers here. One of those folks will fix it. Somebody else will solve that problem. with a unified team building a unified app, people were starting to drown under the weight of all of the communication and collaboration needed. There was so much happening in the code base and so much going on that nobody could keep on top of it all. And folks would end up retreating into their own little silos where they understood what was going on and what was happening in there. On the leadership team, we were starting to ask ourselves, should we keep these values? It was obvious that we were struggling with them. But at the same time, these were things that meant a lot to the team. And at a very fundamental level, these were part of who we were. Now, early on in the project, we'd moved from being a single team, a single mobile team, into a structure consisting of value streams and squads. So each was responsible for a functional area of the app, such as transactions or payments or cards and so on. One of our most experienced Android developers proposed that in the code base, we should do away with the app and services modules. And instead, we should divide the code base up into modules based on features. These align closely with our teams. We'd go from just 2 modules to dozens and dozens. It would bring more structure to the code base. It would give each team their own space in which to work, a place that they were responsible for. And it would allow people to focus on the tasks of their squads, which I can see people nodding in the audience. This all sounds great, right? Doesn't it? Well, as I'm sure you're all aware, whenever you propose a large change, you're going to get pushback. There's always somebody on your team who points out all the problems, who doesn't want to change and needs to be dragged along, kicking and screaming. And indeed, we had just such a person on the ANZ Plus Android team. Now, usually I'm too polite to name names and point fingers, but in this one case here on stage, with the people in the room and on the live stream and all that, I'm going to make an exception and point out exactly who this person was. It was this guy. The one leading the Android team, me. And here we have my big mistake. I didn't listen to the team when they proposed modularizing the code base. I thought that I knew better. And as a technical leader, thinking that you know more than your team, hubris is one of the worst ways you can go wrong. You have to trust the judgment of the people who spend all their day with their heads there in the code. Each week, interested team members would gather together to discuss modularization in a working group that they'd created, and I would be there. Initially, our discussions focused on the pros and cons of modularization, just debating should we do it. It was pointed out that by dividing our code base up into smaller modules, when you made a change, Gradle would be able to limit your recompilation to the code, and that's going to improve our build times dramatically. But I argued that we shouldn't need to contort our code base into an artificial structure to make Gradle's life easier. It should be smart enough to figure out recompilation on its own. Its entire reason for being is managing dependencies and figuring them out. It was suggested that giving each team their own module in which to work would lead to greater independence. And I argued this would lead to silos being formed. Modules that help define a clear public interface between different parts of the app. If you wanted to use another team's code, you just go and call their API. And I argued that this would reduce actual conversations between teams. It would reduce collaboration. Giving each team their own module would allow the teams freedom to experiment with their own patterns, which may be better suited to their code, which I argued would lead to the code base diverging and becoming inconsistent. For every pro-modularization argument, I had a counter argument. And as the discussions continued, it became apparent that we were not debating technical details. What we were actually debating was our principles. The pro-module side valued autonomy, while I valued alignment, which I felt was key to our principle of a unified team building a unified app, which, funnily enough, if you remember a couple of slides ago, was one of the principles we were struggling with the most as we tried to scale. Eventually, one of the team members said something that really struck with me. They said, the structure of your code base does affect the team culture, but it doesn't control it. We believe deeply enough in being a unified team, building a unified product. That value is not going to go away. And there are other practices we can put in place that will continue to ensure that we remain united. And once we realized that modularizing your code base doesn't necessarily mean we were going to lose alignment, I stopped resisting that change, which was the right choice. The team was way smarter than I was. When we acknowledged that our values were important and that changes to the code base would influence those values, it helped us realize that when it came to modularization, we could have our cake and eat it too. We settled on an approach of aligned autonomy. On the autonomy side, every team had their own module they could work in with clearly defined interfaces. You knew how to use other teams' code, and if you wanted to change another team's code, you knew who to go and talk to about it. On the alignment side, we had rules around how a module was structured and templates. There were standards for what a module's public interface looked like, how it managed dependencies, the code quality within them, and so on. And for the most part, this was all automated. We have a dashboard showing code quality and architectural rules were enforced using a tool called ArcUnit. The decision to modularize also helped us with our problem of scaling our values. Rather than giving up on our values, we realized it was instead time to double down on them. With Own It, we needed to be able to clearly explain who owns what. And we needed to be able to describe how we worked as a unified team. Modularization directly addressed this. It allowed us to have clearly defined lines of ownership that were reflected in the code base. And it allowed us to create interfaces between modules that allowed different interaction types between teams. Now I'm gonna go to a little aside here. I just said different interaction types between teams. Well, what does that even mean? When everything was a monolith, you just jumped in and changed some code, right? If you weren't sure what was happening in that code that you were changing, your only option was really to somehow find somebody who knew more about it than you did and hit them up on Slack, which doesn't work when you've got over 40 engineers on the team. Once we added in modules with clearly defined APIs and documentation, suddenly people were able to self-serve. And if you wanted to change the code in another module, you knew which team to reach out to and how to find them. Now that we had agreement on what we wanted to do and why, there was only one thing remaining, the real hard bit, the actual hard work of carving up the code base. The modularization working group produced three big things. Number one, a set of documentation and presentations to the team, explain what we're doing, why we're doing it. Number two, code, which included sample modules and a small template app, allowing people to quickly create new modules following standard patterns. And lastly, a strategy which laid out how we're going to make this large cross-cutting change that would impact the entire code base. I'm going to do a deep dive in each, starting with the documentation. We began by documenting our principles and our goals, basically all that stuff we had just spent ages debating. This kind of direction was fundamental in keeping the team aligned. Another thing we found we needed to get ironed out really early was the question of what size should modules be? It sounds like a really trivial thing. How big should they be? But actually, what size they should be helps tease out one of the core issues of modularization, which is where do you draw the boundaries? A module system where each team is responsible for 20 or 30 modules, each of which has a single screen in it, is going to look very different from a system that has 2 or 3 modules per team with many different screens within them. After a lot of discussion, we decided to err on the side of larger modules. Each team should have only a handful of them. And this is because each module added to the system also brings with it a certain amount of cognitive overhead. They all take up space in your brain. If there are so many modules that nobody can grasp what they contain or how they all relate to each other, then they cease to become useful as a technique for organising code. Choosing that right size is a real careful balance. So to help communicate this to the team, we came up with a set of guidelines and heuristics on where to draw the boundaries. We also produced a set of worked examples where we looked at possible ways for dividing a feature up into module and explained what approach we would land up taking and why. The largest part of the documentation was the design of the modularisation system itself. And there are a number of factors we need to decide upon or take into account. We realised we're going to need a couple of different types of modules, feature modules for user-facing features, platform modules containing things like our design system, and an app module that's going to tie everything together into a buildable, shippable app. We wanted our new modularisation system to reduce the time spent recompiling, help Gradle out. And the key to this, we found, was removing circular dependencies, which meant that each feature module actually needed to be forked out into a separate API and impl module, one containing the public interface, the other containing the private implementation details. And we made a rule that people could only depend on the API module. We also needed to decide on a structure within the modules. We didn't want them to get messy inside each one. So we settled upon having packages for UI, data, and domain, and we came up with standards for the code in a module's public API. We also made sure each module contained a README file, which listed out the public APIs, which team owned it, the location of their Jira backlog, and how to test the code in the module, which was critical in helping the teams find the right way to interact with each other. The best way to communicate the overall design to the team was via diagrams. This gives an overview of the structure that we built. At the bottom layer, we have a set of platform modules containing things like our design system, feature flagging, networking. In the middle, we have our feature modules, each with an API containing a public interface and implementation with the code behind the feature. And note the way those arrows go, that each module can use each other's public API, but not access the internal implementation details. Lastly, at the top level, we have an app module which ties everything together into a buildable app. Let's have a look at the code we produced to help support the modularisation effort. Now, what do developers love above all? It's copy and paste. So our top priority was to produce our first modularised feature, which other engineers could then use as a reference for modularising their own code. We wanted developers to base their own efforts on a known good example, code that demonstrated our principles in practice. We also wanted to reduce the amount of friction involved in creating new modules, so we created a small program allowing engineers to easily build new modules. We used Gradle's build convention plugin to reduce the amount of boilerplate code that was needed. And we used a tool called ArcUnit to ensure that the architecture in each module was consistent. ArcUnit's great. It allows you to write unit tests that ensure you're adhering to your architecture. So if you break the app architecture, the unit tests actually fail. All of this code helped to drive alignment. It ensured that each module didn't become its own little walled garden that nobody else could play in or even understand. At the same time as we were extracting our first modules, we also renamed the app module to Legacy UI and Services to Legacy Services. And we dubbed these parts of the code base the legacy monolith. Our end goal was for them to shrink away to nothing as we carved off more and more modules. But that legacy monolith contained hundreds of thousands of lines of code. It was obvious that this was going to be a long-running, cross-cutting change, so we needed a strategy on how we're going to implement it. Our strategy evolved over time. The first and most important part of it would be setting targets. The Android engineers came together and set themselves an ambitious goal of having 50% of the code base modularized within a few months. Now, again, I'm after a little bit more audience participation here. Warm up your hands. Hands up all of those in the audience who think we hit our target. Whoa, there's like 3. And one of them works at ANZ, so he knows that we're lying. This was a target that we failed miserably to hit. In fact, we landed up going backwards. We added more code into our legacy monolith than we added into any of our new modules. We realized there's a couple of things missing. The first of which was ownership. We hadn't actually sit down and figured out which teams were going to break what code into which modules. Everybody was sitting there across the room staring at everybody else going, yeah, you're going to modularize your stuff, right? So I don't need to worry about mine. We set new, more realistic set of targets, which were based off specific teams, modularizing specific blocks of code. We also realized that since this would affect the pace of feature delivery, we needed to go and get the business buy-in. At ANZ Plus, the business has been very supportive of investing in tech, so having these conversations wasn't an issue. Getting that buy-in helped a lot though, because it meant that people like product owners were aware of the technical changes we're making, and they were able to help push them forward as well. Lastly, we realized that we needed greater visibility on how much of the code had been modularized and how we were tracking towards our targets. The Android team had a solid set of developer dashboards that the team discussed every week. We added stats that allowed us to track the size of the legacy monolith and how much code had been moved into modules, which allowed us to track how we were tracking against our targets and go back and update them, identify who should be responsible for the next blocks of work, and continue discussions with the business. Having that visibility helped turn our strategy into an iterative process where we're continually learning and changing and adapting. And so at the end of 2025, where are we now? I left ANZ early on in 2024, and since then the modularization effort has continued. It's going to come right down to the wire, but like in the next couple of days, maybe yesterday, maybe Monday or Tuesday, they should be removing the very last bits of the legacy monolith. That transition followed an S-curve. At first, things were really slow to get started. Then as roadblocks were removed and the team gained experience, there was a bit of rapid progress there when everybody was modularizing their code. And at the end, it slowed down as only the most complex and intertwined bits of code remained. It was a long journey, but ANZ was fully committed to completing the migration because they realized they won't get the full benefit until all the work was actually done. In terms of the stats, the ANZ Plus Android app has over 180 modules. Each one contains around about 10,000 lines of code, which works out to 5 feature modules per team, which tells me that they've managed to hit the right balance in terms of module size and where to draw those boundaries. Beyond helping to resolve deeper issues relating to our values and scalability, the team has also seen some really tangible benefits of the modularization effort. Because Gradle's able to limit recompilation, there are much faster build times. Each module has a team which owns it, which means code level reporting of things like test coverage can be broken down by team, which means more productive conversations around how to balance tech with feature delivery. And the fact that the code base is consistent, even across all of those modules, allows for wide cross-cutting changes to be made. So if you want to go and refactor all 700 view models, because they follow the same pattern, it's possible. Whenever improvements happen, everybody benefits from them. Let's wrap things up by stepping back. Think about what we have learnt. What actually are the principles of modularization? Firstly, the code you write is a reflection of your values. It's a mirror for your team's culture and principles. Weigh this up carefully when choosing an architecture. This also implies there is no right modularization approach. It depends on your team size. It depends on what you value. Things that work well at one scale will fail at another. For a small team size, you can go with a very simple structure. But as your team grows, boundaries and ownership become increasingly important. Because there's no right approach, both your principles and the code that reflects them can and must evolve over time. Sometimes changes in one can help illuminate changes in the other. When designing an approach, you need to carefully consider communication, team structure, module size. Lastly, you're going to need documentation, sample code, and a strategy. That strategy must evolve over time and needs to be informed by visibility of your progress. So these are the principles of modularisation. This is the slide you take a photo of if you want one takeaway. Thank you for listening to my story. Thanks. I'm very, very happy to take questions, but I also wanted to recommend that you all go and check out Isaac's presentation at 2:20 in the festival hall. He's going to go in a lot more detail about the metrics, measurements, and migrations, including how all those things came together to support that modularisation effort. So I think his talk's a real natural continuation of this one. It's sort of part two.
Right.
Got time for questions?
Yeah. Got like time for 5 questions.
Thank you. Thank you. First of all, thank you very much for this presentation. I'm really interested in modularisation, so thank you. Yeah, I have so many questions actually. Let's say something. Yeah, first I would. Sometimes I was doing some modularisation in my software, and sometimes I was having a problem with cross-module feature, like you want to do a feature, but it could be in both modules. How you deal with this? And also, is it really, can you show us a real-life example? For example, for someone who works in, so this is banking, so like someone who works on pay ID and someone who works on savings, which is same banking things, but two big difference. Can they be switchable?
Oh, big questions, big questions.
Yeah.
Hard ones too. So the first question was, what do you do about, features that could be over here or they could be over here, big cross-cutting things? It's a really hard question to answer.
Yes.
For example, if you open the ANZ Plus application, you'll notice you go to the home screen and there's a bit of a dashboard. There's all kinds of things that you can see on there. Who should be responsible for that, since it's displaying things that belong to and are owned by many teams? There's no right answer. You've just got to spend a whole bunch of time talking it through, having those discussions and figuring out who should be responsible for owning those things. But recall I said that your code, your team structure can influence your architecture. And your architecture can and should influence your team structure. One thing that you can do is you can spin up some sort of platform team that's responsible for big application-facing cross-cutting features to own these things or be responsible. So you're changing the team structure to be able to have ownership of this. Another alternative is you could go in and create some sort of framework or API where like the dashboard is just a pluggable thing and every team can kind of plug their stuff into it and own their own little piece of the dashboard. In which case you're changing the code structure to allow your team structure to remain consistent and still have ownership. So there are options. What's the right one? It's going to depend. It's going to depend on all those things.
What's yours?
What's mine? I don't have an answer because I left ANZ before they figured this one out. You'll have to talk to some of the ANZ people and figure out what direction they went in that one. Did we want to move I know you got lots of other questions.
Thank you.
Dead keen to talk after the break, but let's go to some other people.
Thank you for this. I also have many questions that I'm not going to ask here today. Like, maybe we can take it over Slack. Gonna choose one. So you mentioned Conway's law, and I think that's like really strong force. But coming from a company that's like having reorg fever, every 6 months at least there's one reorg, and all the changes and all the people move all around. I'm gonna completely ignore Conway's law, and I'm gonna go back to the basics and the technical measures. Have something that I've been pursuing, looking for a long time. Maybe you have come across the basics of what's the compilation speed trade-offs. You had a number there that each module had about 10,000 lines of code. Like, is that a good number? Did somebody investigate why that's a good number? Did you see, or did you run any experiments of like how the graph of the gradual modules look good or look bad from the point of view of compilation or anything else?
Yeah, so the question is around like why is 10,000 lines of code a good number? And does it relate to Gradle's compilation speed? What sort of testing and everything did we do with that? It doesn't really relate to Gradle's compilation speed or anything like that. We did a lot of tests early on, particularly when we landed up on that API implementation, modularisation structure, and that came out of a lot of the experimentation that we did. But the 10,000 line thing is more around having a module size which makes logical sense and is a useful mental unit for considering bits of your code base. I think we're up for time, so we'll wrap it up then. Very keen to keep talking and everything today.
All right. Thank you again, Luke, for the modularization roadmap.